To determine the conductor size for a 230 volt, 3 horsepower, 13 amp table saw, we need to calculate the ampacity, which is the current carrying capacity of the conductors. Ampacity equals the nameplate amps multiplied by the conductor correction factor. Assuming the conductors are copper and installed in a raceway, also known as conduits, the conductor correction factor is 0.8 when there are 3 or more conductors in the raceway. So, ampacity equals 13 amps multiplied by 0.8, which equals 10.4 amps. Referring to the National Electrical Code, specifically Table 310.15, B16, we can find the minimum allowable conductor size for 10.4 amps. According to this table, a number 12 American wire gauge, or AUG, copper conductor is suitable. Moving on to circuit breaker size, the circuit breaker needs to protect both the conductors and the motor. To determine the appropriate size, we use the motor circuit protector calculation. The motor circuit protector is equal to the nameplate amps multiplied by the motor protection factor. The motor protection factor is 250% for motors with the nameplate rating of 1 horsepower or more. Therefore, the motor circuit protector rating is 13 amps multiplied by 2.5, which equals 32.5 amps. Based on this calculation, a 30 amp circuit breaker is the appropriate size. In summary, for a Tablesaw with a nameplate rating of 13 amps, 3 horsepower and operating at 230 volts single phase, a number 12 AWG copper conductor is needed. This assumes the conductors are installed in a raceway with 3 or more current carrying conductors. Also, a 30 amp circuit breaker should be used to provide adequate protection for the motor and the conductors. Always consult with a qualified electrician to ensure the installation meets local electrical codes and safety standards. Working with electricity can be dangerous, and it's crucial to take necessary precautions and follow best practices. The National Electrical Code provides comprehensive guidelines for electrical installations, and it is important to adhere to these standards to ensure safety and prevent electrical hazards. Here are some additional considerations. The type of insulation used on the conductors can affect their ampacity. Conductors with higher temperature ratings, such as those with THHN or THWN insulation, can carry more current than conductors with lower temperature ratings. The ambient temperature in the area where the conductors are installed can also affect their ampacity. If the ambient temperature is high, the conductors may need to be deaerated to prevent them from overheating. The length of the conductor run can also affect the voltage drop. If the conductor run is too long, the voltage at the load may be too low, which can cause the motor to malfunction. To minimize voltage drop, use a larger conductor size. In addition to the circuit breaker, a motor overload protector can also be used to protect the motor from overheating. A motor overload protector is a device that senses the current flowing through the motor and trips if the current exceeds a certain level. This can help to prevent the motor from being damaged by overcurrent. It is important to choose a circuit breaker and motor overload protector that are properly sized for the motor. Using a circuit breaker or motor overload protector that is too small can cause it to trip unnecessarily, while using a circuit breaker or motor overload protector that is too large can allow the motor to be damaged by overcurrent. Always refer to the motor's nameplate for the correct ratings. When working with electricity, it is important to take the following safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools. Wear safety glasses. Never work on electrical circuits when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician. The National Electrical Code, also known as NEC, is a set of standards for safe electrical installation. It is updated every 3 years by the National Fire Protection Association. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to follow the NEC when installing electrical wiring to ensure safety and prevent electrical hazards. The NEC is not a law, but it is often adopted by state and local governments as part of their building codes. This means that electrical installations must comply with the NEC in order to be approved by the local building inspector. The NEC is a complex document, but it is essential for anyone who works with electricity. It is important to understand the NEC requirements in order to ensure that electrical installations are safe and compliant. There are many resources available to help people understand the NEC, including books, websites, and training courses. By following the NEC and taking the necessary safety precautions, it is possible to work with electricity safely and prevent electrical hazards. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes for the most up-to-date requirements. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. For the ampacity calculation, the conductor correction factor of 0.8 is based on the assumption of 3 or more current-carrying conductors in a raceway. If there are only 2 current-carrying conductors, the correction factor would be 1.0, and no dirting would be required. However, it's common practice to run a neutral conductor along with the 2 hot conductors in a 230-volt circuit, so the 0.8 factor is often used as a conservative approach. Also, the NEC Table 310.15 B16 is based on conductors rated for 60 degrees Celsius, or 140 degrees Fahrenheit, or 75 degrees Celsius, which is 167 degrees Fahrenheit. If the conductors are rated for 90 degrees Celsius, or 194 degrees Fahrenheit, you may be able to use a smaller conductor size, but it is important to verify that the terminals on the equipment are also rated for 90 degrees Celsius. As for the motor protection factor of 250% is based on the NEC requirements for inverse tie circuit breakers. Other types of motor protection devices, such as fuses or motor overload relays, may have different protection factors. It is important to select a motor protection device that is appropriate for the type of motor and the application. The circuit breaker size is chosen to protect the conductors from overcurrent, but it is also important to protect the motor from overload. An overload is a condition where the motor is drawing more current than it is designed to handle, but not enough to trip the circuit breaker. Overloads can damage the motor if they are allowed to persist for an extended period of time. Motor overload relays are designed to protect the motor from overloads. They are typically installed in the motor starter and will trip if the motor current exceeds a certain level for a certain amount of time. In addition to the conductor size and circuit breaker size, the grounding conductor size is also important. The grounding conductor provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The grounding conductor size is typically based on the size of the circuit conductors, as specified in the NEC. It is important to use the correct size grounding conductor to ensure that the grounding system is effective. Finally, remember that electrical codes and regulations can vary depending on the location. It is important to check with the local authorities to determine the specific requirements for electrical installations in your area. Always consult with a qualified electrician before performing any electrical work. Electricity can be dangerous, and it is important to take the necessary precautions to protect yourself and others from electric shock. Remember, this information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to ensure that electrical installations are safe and compliant with all applicable codes and regulations. When choosing conductors, consider the type of insulation. Common types include THHN, THWN, and XHHW. THHN is a general-purpose building wire with a nylon jacket for protection against abrasion and chemicals. THWN is similar to THHN but is also water-resistant. XHHW is a cross-linked polyethylene insulation that is also heat and moisture-resistant. The choice of insulation will depend on the specific application and the environmental conditions. Pay attention to the temperature rating of the conductors. Conductors are rated for a maximum operating temperature, typically 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. The ampacity of the conductor is based on its temperature rating. If the conductor is subjected to higher temperatures, its ampacity must be derited. Ensure that the conductor's temperature rating is suitable for the application and the ambient temperature. When selecting a circuit breaker, consider the interrupting rating. The interrupting rating is the maximum amount of fault current that the circuit breaker can safely interrupt. The circuit breaker must have an interrupting rating that is high enough to handle the available fault current at the installation location. The available fault current can be determined by performing a fault current study. Choosing a circuit breaker with an adequate interrupting rating is crucial for safety. Also consider the type of circuit breaker. Common types include thermal magnetic circuit breakers and electronic tripped circuit breakers. Thermal magnetic circuit breakers use a bimetallic strip and an electromagnet to trip the circuit. Electronic tripped circuit breakers use electronic sensors and a microprocessor to trip the circuit. Electronic tripped circuit breakers offer more advanced features, such as adjustable trip settings and ground fault protection. The choice of circuit breaker will depend on the specific application and the desired features. Grounding is an essential aspect of electrical safety. A proper grounding system provides a low impedance path for fault current to flow back to the source, which helps to protect people from electric shock and prevent equipment damage. The grounding system should be installed in accordance with the NEC and all applicable local codes. Grounding electrodes, such as ground rods or ground plates, should be installed to provide a connection to earth. The grounding conductor should be properly sized and connected to all metal enclosures and equipment. Regular inspection and testing of the grounding system are important to ensure that it is functioning properly. Surge protection is another important consideration for electrical safety. Surges are transient overvoltage events that can damage electronic equipment. Surges can be caused by lightning, switching of electrical loads, or other disturbances on the power grid. Surge protective devices, also known as SPD, are designed to protect electronic equipment from surges. SPD should be installed at the service entrance and at sensitive electronic equipment. Select SPD with an appropriate surge current rating and voltage protection level. Regular inspection and testing of SPD are important to ensure that they are functioning properly. Arc fault circuit interrupters, or ARCs, are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. ARCs detect arc faults by monitoring the current waveform and tripping the circuit breaker when an arc fault is detected. ARCs are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. When working with electrical equipment, always follow lockout-tagout procedures. Lockout-tagout is a safety procedure that is used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout-tagout involves disconnecting the power to the equipment and attaching a lock and tag to the disconnect switch. The lock and tag prevent the switch from being turned on until the maintenance or repair work is completed. Lockout-tagout is an essential safety procedure that can help to prevent electrical accidents. Electrical safety is everyone's responsibility. By following safe work practices, using the correct equipment, and being aware of the hazards, it is possible to work with electricity safely and prevent electrical accidents. Always consult with a qualified electrician if you have any questions or concerns about electrical safety.